Welcome, my name is Ted Fluher, Solutions Architect with InSource. And in this session we're going to talk about system platform alarming and specifically some of the advanced alarm triggers we have within system platform. So we'll get into things like the rate of change alarm or the deviation alarm. We'll also talk about how we can generate some alarms and have that show up on your graphics using something called an alarm board or animation. And then we want to be able to extract that alarm information from the historical database and do some deeper analysis from that history of the alarms that you have in your system along with the Wonderware Historian. Another great tool we have out there is AVEVA Online Insight. It's a great tool to be able to take your process data, push it up to the cloud historian, create some dashboards, look at data on your phone. We also have the ability to send alarm information up there and overlay that alarm information on top of your trends and look at an alarm in a grid view on Online Insight. And last, we're going to talk about how we can extract information from that alarm database using Dream Report. Dream Report's a great tool to be able to extract that alarm information, put it into a format that can be displayed, look at a Pareto chart, and then potentially email that to you in your inbox in the morning or email it to your team. So let's drill in how we configure these different functions. So to configure the rate of change alarm, we basically have to check a box whether we want this to be looking at the upward slope or the downward slope of the line. And then we also look at the time frame. What's the time frame that we want to do the calculation? Is that per hour, per day, per minute? How often we want to do that calculation and look at that slope of the line? So basically what we do is we take the value at the current sample. Over the next time period, we take the next sample, we determine that difference, we look at that time frame, and then we calculate the slope of the line as shown on the screen. And that's being used to determine whether we're in alarm condition. So let's go take a look at this inside the IDE. So I'm inside my IDE here. I have an object and an attribute defined here called my level, and I'm going to assign it some I/O, basically check the checkbox on the I/O configuration. I'm going to use a simulator here to generate some data. It was going to be my I/O address there. So the simulator is a great tool to be able to extract information from a tool where it can generate some process data for me for testing. And so I go into my I/O simulation, I set up a port, I set up a PLC here, and I choose the algorithm that I want. I can choose a triangle wave, which I'm going to use in this case, but I have other options here. I can have a random number generator or a sawtooth wave. So it's a great tool to be able to generate some simulation data for our testing here. So I'm going to use this tool to generate some slopes of the line that we're going to look at to generate these deviation alarms. So basically in the deviation alarm, we set up a limit. What is that limit that I want to determine the slope of the line is going to change upon? And then also I determine when I'm going to calculate the data on the evaluate every. So we're in that field where I have evaluate every, it's going to execute this calculation. So how do I know what that slope of the line is? So if I look at this trend here, here's my sawtooth wave, and then basically what I'm going to do is determine what that rate of change is. So I'm going to put that over a 1 minute mark here. You can see in the upper right hand corner there, that's 1 minute, and it's changing 50 every minute. So if it's more than that, or less than that in this case, it's going to generate an alarm. So right now my alarm limit is set for 61, so it's not going to generate an alarm condition, either on the upward slope or the downward slope. So, and then I'm going to evaluate that every 10 seconds. So every 10 seconds I'm going to read the value, and then when I read it again, it's going to do the math to determine what the slope of the line is, and then generate an alarm if that line slope has changed within an alarm range. So I'm in my object viewer here, and you can see that's the current level, and that's the different alarm limits, and there's the actual calculation that's being generated here, that minus 40 in this case. But so right now it's 61. So let's go increase that rate. So I'm going to go back into my simulator, and we're going to change the slope of that line, change that angle. So if I look at my trend here, you're going to see it's starting to rise quicker than it was before. Right, so I changed the angle of the line, and what it did, it went into a rate of change alarm. It went to the downward slope rate of change alarm just happened. You can see the color coding on the actual trend itself. The trend itself is highlighted in yellow, saying it's a high alarm. On the upward slope, we change that priority to be a high alarm, so it's going to be a different color. So when this goes in the upward slope, it's also going to start generating alarm. After that 10 seconds, it's going to wait for that. There it is. It just generated that high alarm, high alarm, and you can see the color coding is on my trend chart indicating that that line slope has changed. So it's a great tool to be able to determine, if the slope of the line is changing too quickly, you're decreasing that tank level too quickly, or if you're increasing the temperature of a process variable too quickly. It's a great tool to be able to do that. So I'm going back into my simulator. We're going to put that back where it was, and then we're going to see where it goes out of the alarm conditions and back to the normal waveform that we had over there, and then generate that data. Right. So there it is. It's out of the alarm condition, and then it's back to where it was before. So again, great use case for the rate of change alarm to be able to detect when there's a slope change. Also, one of the things that we have now with storing our alarms in our historical database, we can store things like when an operator acknowledges alarms, and we overlay the alarm information on top of a trend. So you can see on the alarm, on the trend chart there, you can see that the alarm indeed was acknowledged, and that shows up on the actual trend control. So some nice new features within System Platform for alarming capabilities. I can overlay that alarm information directly on my trends. I can see when an operator acknowledged an alarm. I can see the status of alarm conditions within my trend controls. So great tool for seeing alarms within my System Platform. If you haven't noticed, in the background here I have something called OMI. Those who haven't seen OMI, it's a great tool. It's our newer generation HMI, but the whole idea with OMI is I can click on an asset and all my panes come into focus. So I'm clicking on, say, one of the assets over here, my map app here. So if I click on that asset on the map, it's going to take all panes into that map control. The next alarm parameter we have within System Platform is a deviation alarm. And deviation alarm is used to determine if we're starting to skew out of control from our set point. So typically in process control, we set a set point. If our process variables start tracking out of control, we want an alert on that. So what we do is we set it up inside our IDE. We basically can have a minor deviation alarm or a major deviation alarm. And then we can set our target. Target in this case is hard-coded, but we also can put a script in there that's going to overwrite that target on the fly. So if we change our set point, we'll be able to track that set point. And we also have the ability to set up a deadband. So we have to drop out of that situation, that alarm condition, and back into alarm condition for it to happen again. And then we also have a settling period. So when we make a process change to our set point, we want to have it settle down before it actually generates an alarm. So I'm back here in the IDE. I'm in my heat exchanger. I have a couple different attributes here. I have a deviation, I have a noise, and these are being used to pass that information to our simulator, and our simulator is going to be able to track that process variable against a set point. So when I change my set point, the process variable will track. So basically I go here, I set those tags up, the simulator recognizes those attributes, set points, and process variables. Then I also set my deviation alarm checkbox here, and this is where I can say I have my major deviation, my minor deviation, and give it those tolerances, what those alarm conditions are. I can set a different priority I have up on those different systems, so it's basically a different color on my alarm display. So this is everything that needs to be done inside the IDE. Once I save that, and then I can deploy it, check it in, all those kinds of good things we do in System Platform. And there's my target. And there's going to be a script behind the scenes that's going to overwrite that target. And there's that deadband that we talked about. Right? And this is the settling period. So when I do make a process change, it gives it some time for the process variable to catch up before it generates an alarm condition. So let's go see how this is done. Let's open up that object viewer. We're going to introduce some noise here and take a look at that. We also have that script behind the scenes. This script here is overwriting that set point. So the set point is being used when I make the set point change. It's going to overwrite that variable that I have hard-coded here. So it will track that, and it'll go basically generate that alarm condition based on the new set point. So I have object viewer over here. You can see I have some attributes I'm looking at. So right now I'm not in an alarm condition. Everything is good. My tolerance is set for 3. My simulator is set for 2 as far as the major deviation I have there. So I'm going to increase that here. I'm going to go give it some more noise and increase the actual simulator, the flag that's getting generated by the simulator. And then also you can see on my process chart here, you can see when I change the set point, and you can see the process variable is now tracking. Right, so that's a nice feature with our trending control, that we're tracking when operators do things on the actual trends themselves. So great tool, this simulator I'm using here, to be able to track the process variable. Looks like it had a pretty nice PID loop here, so it tracked pretty quickly, and it's still in control, right? So it's not out of control at all. It's still in my condition, within the alarm band condition. So everything's looking good here. So I'm going to go put it back to where it was, so it centers it on my screen, and then we'll introduce some more noise, and we'll give it a more a deviation to generate the actual alarm. So you can see it skewing back into control. We'll let it settle down there a little bit, and then we'll introduce some more noise to the system and generate a deviation alarm. So I'm going to go change that deviation set point there in my simulator, so it's going to generate an alarm because it's going to skew out of control from that actual set point, and introduce a little more noise here. So right now you can see that it did. Those trend controls in yellow meant that the set process variable skewed beyond the actual set point, and it generated that minor deviation, because that's the amount of deviation we specified in that simulator. So great use case to be able to track when we start going out of control from our set point. So let's go back in here and let's go change our deviation in our simulator to see if we can generate a major deviation alarm. So we increase that to 20. I'm going to give it a little more noise here to make it happen quicker. Again, this is kind of a random function that's happening with the simulator that I don't have a whole lot of control over. So we just save that, and let's see what happens. There we go. We just generated a major deviation alarm because we did indeed drop below that threshold for that deviation set point. So again, we're showing it up on our trend control, showing it showed up in red, showing us we do have a major deviation. If I hover over that, it's telling me I have a major deviation alarm going on in the system right now. So let's go back into our object viewer. We're going to increase the actual set point, and let's see if it tracks here. So I'm going back into my object viewer, and then we'll get that information back into a new set point and see if that process variable tracks, and see if it goes into a major deviation. So changing our set point, you can see it on the trend control. Set point was changed. It made that note there. There was an operator to change that set point. Our system is tracking. We dropped out of a major deviation. Now we're back into a minor deviation, and we'll watch that and see if it drops back into a major deviation situation here. There we go. It went back into a major deviation. So you can see it's a great tool to be able to determine if I start skewing out of control from my actual process variables. And again, that script behind the scenes is changing that set point based on what the operator changes. So I don't have to go back in the IDE and change that if I'm making a set point change. So let's talk about a relatively new feature we have within our graphics, the ability to enunciate alarms on the actual graphics to get the operator's attentions. And we saw previously we can enunciate the alarms on the trend controls and things like that. But if we want to get the operator's attention, we have some built-in functions that allows us to do that. So we're going to go here and generate an alarm on our process. And we're going to see this alarm border animation is going to show up. So I just generated a level 2 alarm. And you can see over on my map application, around that pin around Lock Raven, it's showing me I have an alarm condition. That's the alarm border animation. And if I go over to my graphical element also has that configured to generate that alarm, that level 2 alarm. So let's go generate a high level alarm, a level 1 alarm here. In this case, we're going to go change that set point to give that alarm a higher priority. So go change that value here. And then on my graphic, you're going to see that alarm border animation is indeed going to change to red, telling me that there's an alarm condition at a higher priority and gets the operator's attention. It's flashing right now because it's unacknowledged. If I did acknowledge that alarm, it would stop flashing, and if the alarm went away and it was not acknowledged, it'd kind of be a red grid around that device. So great use case to be able to get the operator's attention with the ability to put alarm board or animation around any of my graphics. No matter what I draw, I can see that information. So something else we have in the system platform is the ability to just click on the alarm banner and it's going to take me to that alarm. So I moved away from that Lock Raven, but you can still have I have a Lock Raven alarm here. So if I double click on that Lock Raven alarm that's in the bottom, it's automatically going to take me to the page associated with Lock Raven. So that's something we've been wanting for years inside of InTouch, and it would take a lot of scripting to make that happen. But I'm going to double click on the alarm banner, and then it's going to change all my panes to the actual Lock Raven asset there, and all the panes are going to be in focus with that. So another great tool we have within OMI, which gives us the ability to generate an alarm and navigate to the page that has that alarm associated with it. So now let's go take a look at how we have that alarm border configured, how we configure the alarm border animation within the IDE. So you can see there's that pin that I had on the map. So if I double click on that, it's going to show me the animation feature, and I turned on the alarm border. Basically, I hit that plus bar there, and it's going to show up the alarm border configuration. I give it the actual process variable that I want to link that to, and then it's going to generate that alarm border around any graphic. And it does some other things automatically here for us as far as what's it going to do when it's acknowledged, and what's the severity of the alarms, and that information. That all gets filled in for you automatically, so you don't have to worry about that. Just put in that process variable, and then it'll go get that alarm information, and then when that alarm gets generated, it'll put that border around it. So no matter what you draw, it just could be a rectangle or a square, you can check that box to say I want to put alarm border animation. I also had one of the newer orchestra graphics, the situational awareness graphic library symbols on the screen, and that has a built-in function to enable that alarm banner. So if I click on that indicator I have here, I basically have to turn on that property to enable that. So here's another use case for the alarm border animation, right? So one of our demo systems showing you that, hey, I have an alarm border around my turbidity. It's used to get the operator's attention, that he wants to be able to see what's going on there. So I'm looking at an overview that also has an alarm border animation. I drill into that. My turbidity has that alarm border animation around it, that level 2 alarm, to get the operator's attention. So one of the more recent features we have with System Platform is the ability to store the alarm information, the alarm history, into the AVEVA Historian history blocks. So if we go into the configurator, this is where we configure that. We tell it we want to go use the high-speed history blocks to store the data. And that gives us the ability to see that trend data, or the alarms overlaid on top of the trends, and be able to pass that information up to online insight. So a great use case for the alarm information, store that in the Wonderware Historian, and then be able to do some correlation between the Historian trends and the history blocks. The way we extract the information, if we go into the Historian, the runtime database, the way we go get that history files is we go into a view called the events view, and basically we look at the events view and we query that data. So here's a query of basically executing all the columns from that event view, and we give it a time frame, and you can see there's some of the data we've been playing with, some of the alarms we've been generating with our test scenarios we've been dealing with. So a great use case to be able to extract the information from the database because it's stored in our history blocks. Even though it's stored in our history blocks, it makes it look like it's SQL databases and SQL tables using that view to extract the information. So once that data is inside the history blocks, we have the ability to push that information up to AVEVA Online Insight. So AVEVA Online Insight, I go in and I choose the tags that I want. So if I just double click on the replication, and I tell it I want to replicate that to Online Insight, and I choose the tags. In this case, I have chosen already some tags, but I have to log into that Insight application. But there's the credentials, and there's the query that gets sent up to Insight. But basically, if I want to replicate some tags, I say I want to add multiple tags. I pick my tags from the list. I have some already chosen here, and these are all being replicated up to AVEVA Online Insight. So basically, go in the Historian, pick the tags that you want, and they say replicate that, and it's going to automatically generate that up on Online Insight. So once it's up on Online Insight, For those who haven't seen Insight, Insight's a great tool to be able to build dashboards and look at your data in the cloud historian, and the data can come from any Wonderware data source or AVEVA data source, from the historians, or InTouch or Edge can push data up there. So if I go look at that trend of that rated change alarm that we've been playing with earlier, you can see that alarm information is overlaid on top of the actual trend. So every time it went into that alarm condition, we can see that. So that's the beauty of storing that the alarm conditions inside the AVEVA historian, because it gets pushed up to the cloud also. So both getting pushed up there. We also have the ability to go look at this in a grid view. We can see all the alarms that were generated, and they're also available to us on AVEVA Online Insight. So you can see here some of the tags that we've been playing with when we were doing the rated change and the deviation alarms, and we have some flow signals there. So they're also being shown up here at AVEVA Online Insight, and I can export this information or do other things with it, but it's all displayed for us at the Cloud Historian. One of the other things we can do with data up at Online Insight regarding alarms, we can generate alerts. So if we pick a trend control here inside of AVEVA Insight, and I say I want to add an alert, I click on that icon, and it's going to generate an alert based on these conditions here. So I can tell it what the condition is. It's greater than or less than this particular value. And it's going to send me an email and send me an alert on my smartphone when this condition occurs. So it's going to say alert me here in this case. I can add other users to the list. So it's going to send me alert. It's not going to have the full-blown acknowledgement capabilities. But I also have the ability to do this on my smartphone, right? So if I look at the AVEVA Insight application, there's an app associated with that. And you can see there's some pages I already have configured. So if I click on one of my trends that I have, and then if I want to add an alert to it for this station flow, basically I just do a long press on it, and I can look at the information in a trend control. But if I do that long press on that, it's going to give me the ability to add an alert. So I'm going to long press, and there's the add alert. And I can say, okay, notify me when this station flow 777 is greater than 50 in this case. So it's going to generate an alert. So I just did that on my smartphone. And let's wait for that thing to generate an alarm. And we'll give that 1 second. And there you go. An alarm got generated on my phone. I can click on a little icon up on the top of this smartphone app and show me all the alerts I have currently going on in this system. So a great use case. This all started within System Platform, checking those different alarms, whether it's a deviation, a rate change, or a level alarm, or a state alarm. I can push it up through my AVEVA historian, get it up to the cloud, and then it makes its way down to my smartphone no matter where I am. If I'm on the golf course or I'm out on my boat, I can see all this information. So great use case for another alarm function that we have within System Platform. So earlier we talked about how we can log alarms to our database. We can use some tools that we have with Dream Report to extract the information from that alarm database and give you some nice reports here showing you the breakdown by priority and criticality of those alarms. We also can do a Pareto analysis to determine what the bad actors are out there, to determine what alarms are causing nuisance issues for your operators. And one of the worst things you can have is a nuisance alarm going off and your operator becomes numb to that. So great tool to be able to extract that information, get you some visibility into those alarms and what assets are causing the problems out there. So great tool, layers right on top of the Wonderware AVEVA historian databases and understands all those structures of our alarm databases. Another example of a report showing that information, same kind of thing, showing the different severities of alarm, also doing a Pareto analysis. So great tool to be able to extract that information. Dream Report also has a great tool for generating batch type reports, and also you can generate the alarms based on the batch. So you could trigger an alarm or trigger a condition at the end of the batch to send you a report that includes all the process parameters and all the batch alarms that happen. So great tool to look at beyond just alarming, does all kinds of process graphics and data with your reports. Well, thank you for joining us in this session today. If you have any questions about any of the content, please contact me at the email address on the screen.